Hello, I'm Mr. Hughes and I'm going to take you through the task-based assessment for the Applied Science course. Now in this specimen example we have some background information which you'll always get in the task-based assessment, and this one gives you some information about a food packaging label where you can see the amount of energy, fat and saturated fats and sugars and salt in a particular item of food. So you can see that we're going to be looking at energy and food in particular in this example. Now, they've also given you some other information here about the assessment summary. We will need to plan our experiment, this is task A. We've got to collect and record data as task B. And then we've got to analyse the data and draw conclusions, which is task C. They've given us an equation here, and so this is an equation you may want to use in this example where we can work out the energy released per food per gram in joules. And then in task D we have to evaluate our procedure and our data, okay, to assess the quality of data we've achieved from the method we've used. Then you will always get a list of apparatus to help you with task A in your planning, with some visual aids if you're unsure about what some of the items are. So here you can see the clamp stand with the boss and clamp and a Bunsen burner. Now you don't need to use every piece of equipment here. So when I'm going to write my method, I'm not going to mention things like the pencil and ruler. I think that's a bit necessary, but you use what you think is suitable. Okay? Right. So you will always get questions like this when you have to do it. What variable will you change in your experiment? Well, I'm going to investigate how much energy is in different types of food, so I'm going to be changing the type of food. What variables do you need to keep the same in the experiment? These are your control variables to make sure it's a fair test. The two obvious ones for me then, if I'm burning food, is that I need to make sure the distance between the burning food and the water is the same each time, and the volume of water I'm using to measure the temperature rise is the same, so I've actually indicated how much I'm going to use, 20 centimeters cubed. What will you measure in your experiment? Well, I'm going to be measuring the temperature rise in the water. Okay. Then, what equipment will I use? Well, I'm going to have 5 samples of food, a boiling tube to put the water in, the clamp stand and boss and clamp to hold the boiling tube, a Bunsen burner to light my food, a measuring cylinder to ensure I can measure out 20 centimeters cubed, so I'm going to use a 50 centimeter cube measuring cylinder, some tongs or a mounted needle to hold the food, a thermometer to measure the temperature rise, and obviously some water to heat up. Okay, I've bullet pointed them here just so it's clearly laid out for me. Okay, but you don't have to do that. Then I have to write a step-by-step plan for my method. So I've gone with 12 steps here to do absolutely everything I'd need. Okay, yours may not need to go up to 12 steps though. Now, step 1, I'm going to measure 20 centimeters cubed of water into the boiling tube. Step 2, I'm going to measure the temperature of the water using a thermometer and record it. 3, I'm going to weigh a sample of food and record it in grams. Then I'm going to pick up the food with the tongs, hold it in the Bunsen burner so that the flame ignites the food and it catches light. Then I'm going to place the lit food underneath the boiling tube of water. Step 7, I'm going to hold it there until it is all burnt. Now if the food goes out, but I suspect there's still more food to be burnt, I'm going to put it back into the flame to relight it. However, if it does not relight, I can assume then that food has been completely burnt. So step 8, when the food is completely burnt, I'm going to measure and record the temperature of the water again. And now I can calculate the rise in temperature from the start and at the end after I've heated it with the burning food. I'm then going to calculate the energy released using the equation that was given to me earlier. Okay? Your practical may or may not involve an equation, but they've given me one here. The mass of the water, which if I'm using 20 centimeters cubed would be 20 grams. The times the temperature rise, that's what I'm going to be measuring, times 4.2. This is a figure they give you. This simply refers to the specific heat capacity of water. Don't worry about it though. And here's the mass of the food sample. So I can work out the energy released from the food per gram. So I need to know the mass of the food in grams. So I'm going to use this equation because I want to get as many marks as possible. But you don't have to, and you may not even have an equation to use in the real one. After I've worked out the energy released, I may compare my results with the energy given on the packaging. If there's time, I may look to do repeat experiments. And then, of course, if I do repeats, I need to calculate a mean. Now, a quick risk assessment. for this procedure. Now, what is the material or activity that I'm looking at? Well, using a Bunsen burner and lit food. Now, the hazard here is that there will be a flame. Now, the risk is what can go wrong with that hazard. Now, I could burn my skin or the flame could go in my eyes. So I'm going to take care when handling, and I'm going to wear eye protection. Another material activity that I might need to risk assess is the use of glassware, the boiling tube. This is glass, okay? And the risk is that could be broken. And if it's broken glass, it could cut the skin. Okay? So I'm going to again take care when handling it, and of course wear eye protection to protect the eyes. Now, you will then be asked to record your data in a table. Now you can see I've constructed one here that allows me to record the mass of the food, the temperature rise in the water, and then using this equation up here, how much energy was released. Okay? But when you draw your table, it may be that you don't have to do these complicated equations. So when you come to draw your table, you need to have the thing you're changing down here. This is your independent variable, the thing you're changing. And then the thing you're measuring here. So if I was you, I would always think about when I'm measuring something, if there's time, to do try 1, try 2, try 3, and then calculate my mean. Okay, so this is what you're going to be changing. This is what you're measuring, and I'm going to do it 3 times and calculate a mean. However, in my table for this example, I'm not going to do that, but this is what you may want to do in the future. 3 tries and a mean. Then it's task C, where you're going to analyse your data and make some conclusions. So first of all, they're going to ask you to find out what is the result from your investigation. Now, in my investigation, I found that the biscuit contains the most energy. Okay, I would know this because I would look at my results table and just find out what my results were. Okay, and yours, which one had the highest or lowest mean, and whichever it might be the thing that you're measuring. Now, how do I know that it had the most energy? Because it had the biggest temperature rise in this experiment. Then it's asking you to look at your data, and it's asking you to put the food in the order of energy contests, highest first. So my biscuit was the highest, then the crisps, crackers, cereal, and then pasta last. Okay, so this is basically a question that's asking you to look back at your table and to find out which had the highest mean and the lowest mean from your results. Then, using the information you've collected, they may ask you to apply it to a situation. So now, what advice would you give consumers who want to reduce their body mass? So, in this example, I'm going to tell people that they should reduce the amount of food they eat, which is high in saturated fat, and reduce the amount of food they eat, which is high in sugar, because these contain the most energy. I'm also going to advise them to exercise more, to use up any energy that they have stored as fat in the past, and that will allow them to then reduce their body mass. Okay, so whichever results you get, you'd have to refer back to it and draw conclusions from the data you've collected. You will then be given some graph paper to record your results in. Now, in this case, I have got different types of food. Okay, so when I've got something which is words that I'm changing, I would need to use a bar graph like this. But if I was changing something like temperature or time, anything with numbers here, then I need to draw a line graph. Okay, so this would be drawn differently. Now, this is a bar graph, and when you use a bar graph, it is nice to put a little gap between the bars. Now, don't worry if you find that difficult, just bunch the bars up, but you should show a gap between the bars because these are different discrete variables. Then, with the bar graph, up the side, I need to make sure my axes are labelled. So this is temperature rise in food and include the units. And this is, of course, my type of food. And in this case, then, I don't have any units for this, so I don't need to put units in. But if it is a variable with units, make sure you include them. Okay? Plot your bars accurately. Choose a sensible scale. Here, this is the most simple scale you can have. There's 10 little squares, and I'm going up in 10 for every 10 little squares. So I know that each square is worth 1. Okay? So, for example, answer of 74, I just got 4 squares from 70. But just check and find out what your scale is worth. So if each square is worth 2, you go 1 block for 2, for example. Right, task D is to evaluate your experiment. Now, how suitable was your method? have a look back. Did your method give you results where there was a clear pattern or trend? Did your method include things that made sure it was a fair test to give you some valid results? Okay, was your method particularly accurate or not? Now, this experiment is not the most accurate, so here there are several ways where we can improve the experiment because of causes of inaccuracy. So, there were causes of inaccuracy in this experiment. The heat may have escaped into the surrounding air. The thermometer may have been touching the hot glass at the bottom of the boiling tube, and so the temperature rise was not just from water, it was measuring the temperature of the glass. The apparatus I used wasn't insulated, so the heat may have escaped more there, and the water wasn't stirred. Okay, so how can I improve the method? I could have insulated the apparatus to stop the heat escaping so it doesn't leave the boiling tube, or it doesn't leave the sides when the food's being burned. Also, I could have used a clamp stand perhaps to hold the thermometer in the water so that it did not touch the glass boiling tube. And I could have stirred the water to make sure the heat was distributed evenly, okay, and not just hot water at the bottom and cooler water above. And then the final part of the evaluation is to look at the quality of the data. Now here, were your results repeatable? These are the sentences you may want to use. You might want to say, my repeat readings were very similar, so my results are repeatable. Or, if your repeats varied a lot, and they were quite different, you would then say your results were not repeatable. Okay? We're not looking at reproducibility here because you shouldn't be looking at other groups' results. This is simply looking at your own results if you did repeats. Now, were there any anomalies or uncertainties in your data? It may be that you found the odd result was a little bit different to the rest. So for example, you could say, my result for crisps on try 2 was much lower or much higher than the other repeats, so I did not use it to calculate a mean. So just look for any anomalies. These are results which are much higher or lower than you'd expect. Now, was I fully convinced about my conclusion that biscuits had the most energy? Well, my method included control variables, so it was a fair test. I did repeat readings to check the results were repeatable. If you did not do repeat readings, you may want to say here that I cannot be fully convinced about my conclusion because I didn't do repeat readings. Did you see a clear trend or pattern in your results? It may be the trend was quite clear, so you didn't feel the need to do repeats. In my experiment, it was very inaccurate, so I'm going to write that, however, even though there was clear results, the method wasn't the most accurate, so I am unsure about the validity of my conclusion that biscuits had the most energy. Okay, and that is all.